Good morning. The end of a short week, right? Because we had Monday off, and at least it feels like a short week. It's going to be a long day. Today I teach at another campus, so I'm going till about 4 o'clock today, almost straight through. So we'll see how I am. But fortunately, I have no classes on Friday. So again, remember, if you're struggling with any of the questions, Friday's kind of my office day at home. I can meet on Zoom if you need to, so we'll do that. Remember, each lecture has been recorded, so you can go into Canvas and do that. Let's first see where we're at. So today, let's go here. Why is this? Let's try this again. Okay. Okay, it's clear. So today is the last of the new content until we get to the first exam. What we're going to see is it's really the same thing. It's a method for taking a derivative. So remember, take the exponent down, multiply, and subtract 1. So that's kind of what's going to be going on in the background. There's nothing new to that, but there's sort of a process we're going to have to go through for product and quotient rule. Next week, I moved the 11.4, which will not be on the exam anyway. We made it a review day by unanimous decision. So we will have 2 review days next week. And then the test will be the following Tuesday on September 19th. So that's, and it will be in here. It's a paper version of the test. I haven't seen the actual exam yet. I'll get you more details, but I'm sure it's much like last semester. There's about 20 questions. 13 or 14 of them are multiple choice. You just have to choose the right answer. You can provide supporting work. That's always helpful in case for partial credit, but if you got the right answer, that's good. Then there'll be a few that are sort of essay type answers where you need to show your work. And I'll give some examples. I'm not going to get critical in grading the work that you have to do it in a particular way, but your work should show that you understand how to get to whatever we're doing, okay? So give me a correct answer, give me some supporting work, and you're all good. If you've got an incorrect answer, that's when I go and I look more detail into the work. Is there something in the work that shows you understand some of it? So that's what I look for. And that'll be it. So what I would like over this weekend is, of course, for you to be working on the 11.3 and anything else you haven't finished yet. But I also want to point out here that we have right under here in Canvas, this review for Exam 1. It's a PDF file. You can print it out if you want, or you could just screen it and start working through some of these questions that are in here. There is the actual questions. There's also, wait a minute, what is there? Oh, this is the first one. It's the course resource page where I got these from. So if you ever want to work ahead, you can always go to the resource page. It has all the reviews. I will then also post them in here so that they're more accessible. So you can get it here, and then there's a solution guide. Okay, so I've shown these a few times, but there will be types of questions that you need to answer. There's no multiple choice ones here, so it's not really a practice test, but this is the type of content we need you to have learned. And you'll see they've got stuff from all of the sections we've covered all the way to 11.1 and 3 are up here, and then we've got the marginal analysis, which we just did on Tuesday. A few questions here. And in the solution guide, sorry, I went back too far. In the solution guide, there's the correct answers. Sometimes there are some detailed explanations for those answers. So in the past, I hadn't actually done any solution videos, so I don't have any on test 1. Usually I'm running behind. I will work this weekend to look at some of the more challenging ones. I'll do those first, but I'll do a few of these solution videos. So if you get stuck on one, you could click on the video link to it, and I will actually work through it and kind of explain it. So that kind of gives you a, just in time that you can work through things. Doesn't mean that there still won't be other questions, and that's what we've got next week for during the review. We'll see how that review goes, and if we need, we can also set up maybe a Zoom session for another smaller review, maybe at the end of the week, but we'll work through that next week, what we're going to do. Okay. But again, my goal is that you're well prepared. You do really well on this first exam, because typically I find those who do well have a good understanding. They do well on the second, the third, and the final. Those who struggle, you still can recover, but again, right now we want to just put positive vibes out there. We are going to do good on this test. We're going to be well prepared, and we're just going to keep going with this. Okay, and then we'll talk about options later on. But it's not certainly not the end of the world if you don't do well, but it just means we've got to set up a recovery plan. So, excuse me. So we're going to look at, again, the derivative, and we've got a couple words for the derivative now. We've got the derivative. What's the first thing? How were we introduced to what the derivative is, graphically, geometrically? It's the slope of the tangent line. So that was one that we've got several, and they're not in here, but several times we've got to visualize what that tangent line looks like. And remember, a tangent line goes through the graph at one point. Sometimes it actually goes. Remember, there's kind of different tangent lines. It can go through more than once, depending upon the graph. But locally, it's going through one point, and it's that slope of that tangent line. So that's one of the things we want to do. That's what the derivative is. It's the slope of the tangent line at that point. On Tuesday, we picked up another word we can use for that derivative, that slope of the tangent line, in terms of business, cost, revenue, and profit. What was that other word? It starts with an M. Marginal. So the word marginal in this class refers to the slope of the tangent line, the derivative. Okay, so we've got these three words that really, if you see them, they're asking you to do the same thing. Today, we're going to go back to sort of the abstraction, and we're going to say, well, what if we've got two functions that are being multiplied? How do we take its derivative? Okay, again, we can think of what we're getting. If we were to graph it, it's a slope of a tangent line. That's what we're trying to find. It would be a marginal if it's two things being multiplied, and sometimes in business that happens, right? You've got two functions, one is a cost or something, and you end up multiplying them. Sometimes revenue may be that, because you've got different revenue streams, and maybe there's multipliers or something. So that's the setup here. So let's go through a little discussion of the product rule. We're going to come up with a sort of a simple formula for doing it, but if I just give you the formula, okay, let's do it. I want you to understand why we do this. And so to do that, I'm going to go all the way back into algebra and talk about something that hopefully is fairly clear. So we'll go to algebra. And I want to compare. When algebra, we were adding two things, say 2x squared plus 3x, and we were adding 4x squared minus 7x. What would we do? It's addition. We're not talking derivatives. We're not talking calculus, algebra. If we got this and we're asked to simplify it, reduce it, whatever, what do? We combine like terms. Okay, good. So we've got squareds. We add those together, and that gives us 6x squared. We've got a 3x and we've got a 7x. Those are like terms, so one's positive, one's negative. And so we're subtracting, actually, we'll get a negative 4x. Okay, so that was, so addition, subtraction was fairly easy. We identified like terms and we could add them together or subtract them, whatever the cost may be. And that's sort of what we've been doing so far with derivatives, right? Term by term, we've been taking derivatives. We've been doing the sum or difference rule, right? Adding or subtracting. But in algebra, when we got where we were multiplying two functions, this was a little different, right? We couldn't just, take the like terms and say, okay, this is going to, let's multiply the x's, and well, that gives us x squared, and then let's multiply the numbers, that gives us minus 12. Oh, that's cool. We're done, right? No, we got the wrong answer. We're missing something. That's part of what we do. These are not equal. What we did is we picked up this sort of process called FOIL. Okay, and we're not going to actually be doing this today, but something similar. So what we had to do is with algebra, we had to multiply the first. So yes, we did get x squared first, and then we had to multiply the outers. So that gave us a negative 3x. We had to multiply the inners, a plus 4x. And then we had to multiply these out here, and that gave us our minus 12. So we were sort of close, but we're missing something in the middle. What we were missing is that the actual answer is x squared plus x, because these are like terms now, minus 12. And we probably spend a lot of time when we were taking algebra learning that FOIL, how to multiply things out. And that multiplication is different than adding and subtraction. Okay? What I want you to think about is when you were learning that, maybe some of the struggles you went through, how did you teach yourself this FOIL process? And there's various ways to go through it. That's what we're going to need to do something when we get into the derivative. Okay? So let's start off with an example. In fact, let's take this one, x plus 4 times x minus 3. How would we take this derivative? So I'll use this symbol, d dx. Now with the sum rules, we just sort of went term by terms, but notice if we did that, if we say, okay, let's take the derivative of this first part, that derivative of x would just be 1. Derivative of 4 is 0. Let's take the derivative of this part, so we're just taking the derivative of each of these, right? Derivative of x is 1. Derivative of 3 is 0. So does that mean that this derivative is just 2? Or not? Wait, I did this yesterday, didn't I? I did this in my other class. 1 times 1 is not 2. 1 plus 1 is 2, but 1 times 1 is still 1. So that's, I'm finding that's one of my my things. But we foiled it out, right? This is what it would be. What would the derivative be if we took it in the multiplied out? It should be the same, right? But if we take this derivative, we get 2x plus 1. The 12 does go away. This is what the derivative is. It's not this. So this method that I just sort of, let's try it, this does not work. This is not the way to take the derivative. But what we're going to see, there is a way to take this derivative. So let's keep this in mind, that the derivative should be 2x plus 1. And let me, I'm going to introduce it separately, but what we end up doing, let me do this in a different color, is we've got a first part and we've got a second part. So what we'll do, kind of similar to the FOIL, is when we want to take the derivative of two functions, I wanted an f, not a 5, but two functions that are being multiplied, sort of the formula is we will take the derivative of the first, so I'll do it this way, derivative of the first times the second function with nothing done to it. Okay, and then we're going to add, we're going to take the derivative of the second times the first with nothing done to it. So it's kind of like this FOIL. It's similar to FOIL, but it's a little different. So we're taking the derivative of each part, but then we're also multiplying it by the other one with nothing done to it. So let's see how that works down here. So what I like to do is say, well, what's my first part? I'll just call that x plus 4. So what would be my derivative of the first part? Well, we kind of sort of already did that, right? We were doing that down here. Derivative of the first part is just going to be, this is 1x, so I get 1. Derivative of 4 is 0, so it's 1 plus 0, which is just 1. So this is a fairly simple thing. The second function is x minus 3. And so the derivative of the second function is also 1, right? Derivative of x is 1, derivative of negative 3 is 0. And so let's kind of follow this format. Derivative of the first one, well, that's 1, times the second function, x minus 3, so the original, plus the derivative of the second, which is 1, times the first one unchanged. So we distribute through the 1, so that gives us x minus 3 plus x plus 4. Combine like terms, x plus x is 2x, negative 3 plus 4 is plus 1, and look at, we now have the same derivative for this function that we should have had, because it does come, because if we FOILed it out first, we know how to take that derivative term by term. We know that when we FOIL something out here, that's what we get, and that we know how to take this derivative, we know this is correct. And now this new sort of process that just seems to be out of nowhere, it works. Okay? And it wasn't out of nowhere. It took people, smart people, hundreds of years probably to figure that out. How do I take this derivative? And it was a trial and error, and we don't necessarily need to understand how it worked or why it worked, but we understand it. This is the way that works. And for me, learning FOIL, that's what it was. It was just, I'm not really sure why I have to get these, but if I don't get the right answer. So I worked there, and then once I started getting the right answer, as I look back, I started to understand it a little bit better. Okay. And I think that's how this works too. So with the quotient rule, well, actually, I kind of changed things around a little bit. Let's go with this one. We'll come back to the quotient rule later. So this is what we're doing. So we've got two functions being multiplied. We could use f and g. I'll caution you, if you look up on the internet, they do this a little differently. But for me, we're going to see when we get the quotient rule, if you do it the way that has been standard taught, they have you take the derivative of the second one first and then the other one. That always messed me up when I go to do the quotient, because they do it in the other order. But if you do it this way, this is Little Crow's way, because it's different than how everybody else teaches it, how it's all. If you look it up on the internet, you'll see them taking the derivative of the second one first. But with addition, it doesn't really matter, right? But with subtraction, it matters, and that's when I do it the way the books teach it, I always mess up the quotient rule. When I started doing it this way, I stopped messing up the quotient rule. So just take the derivative of the first, right? So that's this one, times the second one unchanged, plus the first one unchanged, derivative of the second. So we're that's how we're going to go through and do it. So this is the formal rule. I think, actually, even I changed it from our textbook. If we go to the textbook, so I changed my slides here, I think. So the derivative of our product is the derivative of the first times the second, plus the first times the derivative of the second. So you take a derivative of one of them, And again, the way you're going to see me do this is I will break it up into the two pieces. I'll take the derivative separately, and then I'll reassemble the derivative. I don't try to just do it straight through, although I probably could, but it takes practice to get there. I'm going to break it into the four pieces. I'm going to use the formula, set it back up, and that'll give us our derivative. So we're going to go through a few examples here. Now, yes, you could just take that x to the third, distribute it through, use the algebra, take its derivative. That's a good way to check to make sure you're doing this right. But what we're going to do is we're going to do it without distributing. We'll check with the distribution. So again, what I do is I list the first function is x to the third, and that derivative of that first function, 3 comes down, subtract 1 from the exponent. So this is now just what we've been doing, right? I come over, what's the second function? Well, the second function is 1 minus x squared. And the derivative of the second, derivative of 1 is 0. I'll go ahead and put that. And then I'm going to get a 2 coming down. 2 times negative 1 is negative 2. Subtract 1 from the exponent, x to the first power. Put that there. So really it's negative 2x to the first power. Okay. I come through and okay, so what's the derivative of this function? Well, it's going to be the first one's derivative times the second plus the first one, not a derivative of the second. Okay. So derivative of the first, and again, I'm just picking my pieces, and this is sometimes where I mess up. So I'll be a little careful here. Here's the first derivative. So that's 3x squared times the second one unchanged. So that's this one here, 1 minus x squared, plus, let me change colors. The first one, just the first one unchanged, that's this one here, x to the third, times the second one's derivative, which is this thing here, minus 2x. And we'll just kind of, so then we've got a little bit of algebra to do. And you might say why it would actually be easier probably to distribute that x to the third first and then just do it. You're right, but this is an easy one that we're going to have to check. So we want to do this process because we're going to get ones that might be like a trinomial times a trinomial. Multiplying those out is actually a lot of work. And eventually we're going to get some other functions where they don't multiply out real good, so we've got to be able to use this process. Okay? So, and the way of learning is we take simpler problems that there's actually an easier way to do them. This is a harder way to do them, but it helps us learn this formula for taking the derivative of a product for down the road. And it also gives us something that we can double check. So again, we've got x squared. It's going to distribute, or 3x squared, so we get 3x squared. That's multiplying by 1, and then I multiply here. That's going to give me minus 3x to the fourth, right? X squared times x squared. And again, you could kind of see if you had distributed, you would have had x to the fifth, which would, when we take its derivative, would be something x to the fourth, right? So that's feeling good. And then the second part we're going to add, there's really, we just have to multiply these two. So that's going to give us a negative 2x to the fourth. And so then we just combine like terms, and our final derivative is going to be, let's see, like terms. These, so 3x squared, x to the fourth are like terms. We've got a negative 3, a negative 2. There's a negative 5, x to the fourth. Okay. We could double check. So if we do distribute first, do algebra first, right? We would have gotten this as x to the third minus x to the fifth. If we take this derivative, which again is a simple derivative to take, the 3 comes down, subtract 1, we get 3x squared. Over here, the 5 comes down, we get negative 5x to the fourth. Oh, we got it. So we could go back and do it the easy way to check it, but the process way now we're setting up. Derivative of, so first function, its derivative. Second function, its derivative. Put the pieces together, we're going to get it every time. It does get more complicated, but if we follow this formula, it's never more complicated. The part of taking the derivative is exactly what we've been doing. There's nothing special about that, and we'll get to a few more but this, so far, does that look good? Okay, and what we're going to see is taking the derivative of a quotient is actually, because we use this formula, it's actually just as easy. It really is just as easy. The formula is a little different, so we're going to have to remember that one. And again, what I do is each time I do it, I write down the formula. I'm not trying to memorize it. If I forget it, I have it on my notes and I'll look at it, but I do write it because what's happening, remember, when I'm using my hand, my fingers or so, it's bringing the brain process up into these sides of the brain, and a little bit further back is the math side of the brain. So I'm activating my brain in the area close to where I need it to be, and so there's some electrical activity up there. It's easy to just tap onto that and get the math going, okay? So as you're doing that, you're building these memory pathways that's going to help you remember, not memorize. I have a terrible time trying to memorize things. I just can't. To me, my brain doesn't work that way. Some of you, maybe you do. But what I do is I remember things that I do repeatedly. If I want to learn to sing a song, I do it again and again and again. But you give me, I can't memorize, that's why I'm not an actor. I wanted to be, but I can't memorize lines. But I can remember things and then ad-lib a little bit. So anyway, find the way that works for you. But I would say have them on the side, some of these formulas, so that you get them right. But if you'll write them each time, it's an extra little couple seconds, but you'll see eventually it'll become internalized for you as well. And then you'll know when you don't need to write it every time, right? Because you'll know, I remember this. So just a little. Okay, so now we're getting to something that's a little more complicated, right? Because the algebra of this, I've got to FOIL out. It's a bit of a steps, right? But now I don't need to FOIL it out because I've got a process where I say, okay, I've got a first function and I've got a second function. And we could do F and G. I just like F and S because F for first and S for second. And again, what I'm going to do to take this derivative, right? Well, maybe not put it here. When I want this derivative, I need the first part. So this is the nice part. I'm just going to copy it. 2x squared plus x. The other thing this does is when you're copying it down, you're learning to show your work, but it's not show your work for somebody else. It's show your work for yourself. You're getting something that's complicated, all this stuff going on. You're bringing it down to something simple. Yes, sir?
When you said you don't need to expand, were you saying you don't need to FOIL?
Right. We don't need to FOIL with this. Now, you could, and then you could check that answer. If you FOIL it first, the derivative would be very easy because it'll be just term by term. The derivative is a little bit harder, but it's actually maybe easier than FOILing out, depending upon what you do. So, no, we don't need to FOIL this out.
But after you get the first and second, that's what.
Right, then we do that to simplify. So we get it set up, and then, yes, then we may need to multiply out. But you'll see that's actually might be a little easier too. So the first one, and then while I've got it here, I take its derivative and know how I've now simplified what I need to look at. I just need to take the derivative of this part. So it's helping me focus, okay, I know how to do this, and I'm not looking at that whole thing anymore. That's maybe scaring me because I don't know how this looks like too complicated. So I simplify down. 2 times 2 is 4. 2 minus 1 is 1. I'll go ahead and put that there. And then the derivative of x, again, this is simple but hard at the same time. Derivative of x is just going to be 1 because it's 1x, right? It's not 0. It doesn't disappear. So that's sometimes what I'll see. It's the number 1. And it's not 1x. The x has gone away because it's x to the 0. Okay? So that. But see, now I've got half of my work done, and then I come over here and I do the second one. And again, you might want to go down. I like to go to the side so I just copy at this point, copy the second function, and then I take its derivative. And again, I can focus now just on the simpler part. I don't see everything else, block things out. And so the derivative of x is 1, right? Derivative of negative 2x, the 2 is going to come down, so I'm going to get negative 2 negative 2x squared, sorry. Subtract 1 from the exponent, so that's x to the first power. So now I have all my pieces, right? Nothing too I mean, this is what we've been doing. And then I just say, okay, what's the derivative of y? And again, this is a part where I do it again and again. This is going to build my memory without forcing a memorization. Memorization to me is kind of like it's like a violence against my brain. But remembering is more natural. All our peoples at one time in our histories was oral traditions. We remembered things well. We heard things once and we remembered it. In our technological world, we've got to take notes and we put things around. There's a saying from one of the tribes in the East that writing is the beginning of forgetting. And I thought, what does that mean? Well, when you write things down, then you can forget about it because it's in my notes, right? Oral traditions, we didn't write things down. We had to make sure we remembered it. So, and again, all our peoples, wherever we were, we might have to go back, like on my dad's side, I'm Saxon. 2,000 years ago, they were indigenous people who were colonized by the Romans, but they had a beautiful oral history. Okay, so we work from those perspectives. So what we got? Okay, we're going to write it down. Take the derivative of the first times the second plus the first one unchanged times the second. And again, you could kind of, you can use any math rules and develop these any way you want, but that's how I'll do it. So what's the derivative of the first one? It's 4x plus 1. And what's the second one unchanged? It's x minus x squared. Now, yeah, they're probably going to want us to FOIL this part out, so it's like we haven't, but at the same time, we're getting a way to take the derivative that's a little bit better. And then the second part, we've got the first one unchanged, 2x squared plus x times the derivative of the second, 1 minus 2x to the first. Now, in a sense, we could, this is the derivative. This is a correct answer. We could leave it here. And this, when you're working through, I would put this here so I could see this. If you make a mistake with the foiling out, that's an algebra mistake, but I see that you did the calculus perfectly, right? We could graph it, and it would give us the graph of the derivative function. We have taken it. But again, just to simplify things, there's always this part. But I want to emphasize that as far as the calculus, we have a correct answer here. We've learned something new. The rest, and this often happens in the calculus class, especially in the engineering version, it's the simplifying, that's where we turn over to the algebra, where the mistakes can creep back in, right? So, okay, multiply 4x times x, that's 4x squared. 4x times x squared, that's going to be minus 4x to the third. Right, so I did this first, and then I did that one. And then I've got 1 times x, so that's plus x. And then I've got 1 times negative 2x. So that's the first part. I've got this plus. And I need to FOIL this part out. 2x squared times 1 is 2x squared. 2x squared times negative 2x, negative 4x to the third. And then I take this one times 1 plus x minus, what's that, 2x squared. Now I combine like terms. So this is, but again, we're back to the algebra. Let me identify the like terms. So there's an x squared there, there's an x squared there, x squared. There's an x to the third and an x to the third. A negative 4 and a negative 4. Be careful. I've seen people do this and they think they're subtracting and they'll put it as 0, x to the third. But negative 4 and negative 4 is negative 8, x to the third, right? So I'll put it up here. Simplifying. So we're going to get negative 4x to the third. And we're adding like terms, so it's not x to the 6, it's x to the third. It's still like terms, right? The x squareds, we've got a plus 4x squared, we've got a minus, so that we're down to 3x squared. We've got a plus 2x, so that gives us a 5x squared. And then we've got a minus 2, so 5 minus 2 is 3x squared. And again, and then what do we have left? We have the x's. We've got a plus x and a plus x. So that gives us plus 2x. Okay. Did I do that right? Because I get. Oh, I said 8x, but I wrote 4x. Thank you. I know there's going to be a mistake, and I didn't do it on purpose. That's not, oh, I wanted you to see if you were paying attention. Nope, I just do it. Well, that's my problem, is it's copy errors. I think I said -8, but I didn't write it because I was looking back down at the -4, and so that's why the more work you show, I can pick up those things, and I know I make those, so I can understand what's happening there. You understand, so I'll take like 1/10 of a point off or something out of 10. Others might no. Okay. Now again, we could do a check. We could FOIL it out and then take its derivative. And I highly recommend doing that as you're doing the homework, just so that you see, okay, this process does work. Again, remember what we're doing here is we're building up, because there's times when we can't just multiply it out and get its derivative. So we're going to need to use this product rule. Sorry. Forget to turn this thing off. Okay. Tax collector or something. No, I don't know any taxes, fortunately. So we good? Okay, so just that process. What we're going to see, we're in good time. So something like this. And again, this came from the homework from spring. I'm pretty sure they probably chose something similar. So we've got two functions. And notice how this homework, at least, they break it. They're kind of helping us because they want us to get the derivatives of each individually. And then what they're going to ask us for, find the rate of change of month revenue 5 months after the introduction of the sound system. So what's going on here? Monthly sales of sound system is given by this. So this is the number of sales in units per month. The price it charges is given by this, the P function. And so what we're trying to get at is find the rate of change of monthly sales. So we do that, find the rate of change of the price. Okay, so that's what the derivative is here, right? Rate of change. Find the rate of change of monthly revenue. Revenue, remember, is going to be number of items, and so that's the items that were sold. So that's going to be Q of T, that's the number of items sold, times the price they were sold at. And again, this is taking into effect that the more that gets sold, probably the price goes down, right? What do they call it? Supply and demand. So the price is actually changing dependent upon how many we sell. And so that's where the product rule is going to come in, right? We've got two functions, one for how many did we sell, the other, what price are we selling them at? And those both are changing. Those are both our functions. We're going to multiply those two together. And again, we could FOIL it out because, they're not too bad. Here's P, here's Q. But we're also going to do this to get the rate of revenue. We need to use the product rule. So Q prime, right, we're up here. In fact, like I said, I like to write them close to each other. But as you see, when I copy things, I have to be more careful because Sometimes that's where my errors come in. So the derivative is going to be what? 6,000. The t goes away. It's t to the first power. And then I'm going to have minus 60 times 2, so that's minus 120 t to the first power. So that's the answer to the first one. But notice I'm setting up my my formula to get the product as well. So for the price, what is the price going to be? Well, again, I'll just copy it down here. It's 3,000 minus t squared. So when I take this derivative of 3,000 is 0. I don't have to write it in. I could. Derivative of negative 2t is going to be negative t squared is going to be negative 2t. See? I can't always talk right, or sometimes I'm going into the future. So anyway, I've got my pieces here. They're kind of backwards, but what's the revenue going to be? It's going to be taking the derivative of the revenue function. It will be the first one. And again, it doesn't really matter because we're adding derivative of q times p plus q times the derivative of p. Okay, and so we can do that, put the pieces together, and I think in this system you could probably get away without foiling things out. I'm not sure if it, but I'm pretty sure you could. So derivative of q is right here. 6,000 minus 120 t, right? Derivative of q times p, and p is the original. It's right here. It's 3,000 minus t squared, and then it's going to be plus. So I'll put the plus, and I'll come down here. Q, the original q, which is 6,000 t minus 60 t squared times the derivative of p, and derivative of p is negative 2t. And again, you can multiply those out. I would try, at least if this is a problem, go ahead and just leave it as it is, because to me, actually, leaving it like this right now it helps me understand the process. Once I multiply it all out, I lose all the process as well. So I prefer to have it left in this way. We just see if the system will accept it or not. I think a lot of times it does, because the way it does a check and answer, it actually, whatever you put in there, it multiplies it out. If I'm wrong, you've got up to 5 tries on that part, so then go ahead and multiply it out. And then what do they ask us? Find the rate of the change of the month. Actually, they want it after 5 months. So I had to do this, but then now I would, I guess, to put this answer in here, this doesn't go in there, I would put 5 in for the t. Everywhere there's a t, I put in a 5, calculate it, I'll get a number, right? So they don't, I needed to sort of make that derivative, but for this answer, I just put that number in there. And then whatever that is, that number goes, this is going to be when t equals 5. This answer actually would be here. That's how much money, that's what our revenue is, how the revenue is changing. So again, always remember, when we've got a derivative, we're getting a rate of change. We don't have how much the revenue is. If we want how much the revenue is, we use the revenue function, which is just p times q. Okay. How's that? We kind of okay. So again, just do some practice with it. It's just, but I just wanted to kind of show you that sometimes in the homework they're actually helping us out and setting it up. So you take the derivatives individually, and then when we're going to multiply, we just have to come over to this sort of formula. Derivative of one times the original of the other, then the derivative of the other with the, follow that. So now we're ready for a quotient rule. Question? No? Okay. I don't want to miss anything. Quotient rule is very similar, but let's think about this. Quotient rule is because we had something in the denominator. When we had something in the denominator, how have we been treating this when we take its derivative? We rewrite it as a negative exponent, right? So the denominator has a negative that comes up. When we take its derivative, that is going to come down. that's going to introduce a negative, and then we subtract 1, we get negative 2. So that's where this squared is coming from, is we're squaring the denominator, is because anything in the denominator is like to the negative 1 power. The negative here, instead of a plus, is coming from taking the derivative of the denominator function. Okay, so the way I like to write this, instead of f and g, I like to go with n and d, numerator, denominator. But again, you could do it either way. And so if I go to take this derivative, so d over dx, the formula I'm thinking of, take the derivative of the first part, that's n, times d unchanged. So this is kind of like a product rule. And I could think of this as a product rule because I could think of this as n times d to the minus 1 power. The thing is if I do it this way, I also need something called the chain rule, which we're not doing until after the test. So it's kind of like I either give you a formula and we do it this way, or we learn the chain rule first and then we don't have to learn a separate quotient rule. But you'll see when we get to the chain rule, it's kind of incorporated. So derivative of the numerator times the denominator unchanged minus, remember, because when we take the derivative of the denominator, it's actually, that's where that negative's coming from. The numerator unchanged times the derivative of the denominator. And then since that denominator, again, we've got to get this negative 2, we would put it back down. We're going to get the denominator squared. And again, I would write this down, print it off, whatever, have it off the side when you're doing your homework. Every time you do a quotient problem, rewrite that formula in the terms that are meaningful to you. Rewrite it as this if you'd like. And you will see, okay, yeah, you'll remember that's a negative instead of a plus. That's really, remember, this is when we were doing the product rule. This is really just the product rule, but the product rule had a plus because it didn't have a denominator. Then the only additional thing is we've got to square the denominator, but okay, that's right, because when you bring it to the top, it comes down, and thinking of what's happening here, right? Because we would rewrite this as negative 1 over x squared. So we started with an x to the 1, and we ended up with x squared. So that's what's going on with every time we do a quotient rule. Okay, and again, we could get into all the details, but again, it took hundreds of years for really smart people to figure this out. I'm not all that smart, but I can copy most of the time. So, and I can learn from that. And so let's see. So again, we're just doing pieces, right? We're doing a top and a bottom, a numerator, a denominator. So maybe I'll go with T for top, whatever you want to do. Again, I just write it down. So this is the copy part, whatever's on the top. And then I'm going to take its derivative. So this gives me 2x to the first power. Derivative of negative 3 is 0. Okay, so that, again, that's just what we've been doing. And then I now need the bottom. Well, the bottom is just x to the 4th. And so the derivative of the bottom is going to be 4x to the 3rd. So that's all the calculus I've done. Now I just need to it's sort of a mix of calculus and algebra. I just need to reassemble it. And I'm going to, I'll call this y, right? And so I'm going to say the derivative of y is what? It's the derivative of the top times the bottom unchanged minus the top unchanged times the derivative of the bottom, all over the bottom squared. Okay, so I rewrite this formula of how, using whatever I need to do, but so what's the derivative of the top? It's 2x. What's the bottom? The bottom is x to the 4th minus, okay, what's the top? That's x squared minus 3. And what's the derivative of the bottom is 4x to the 3rd. And then I divide it by the bottom squared. The bottom squared was x to the 4th. So I square that. And then now let's go through the steps to kind of simplify a little bit, right? 2x times x to the fourth is going to give us 2x to the fifth. And notice, give yourself some space. Part of it is we're going back and forth between taking derivatives, multiplying. So there's these rules. Okay, at this place we're adding exponents. But sometimes if we go too fast, our brain is still trying to take a derivative. Maybe we write it down and subtract one or something. So just make sure your mind is following along, that you're in the right space. That now we're just algebra. This is not calculus. We're not subtracting ones anymore. We're just doing multiplication. In the top, we've got a, well, just distribute, right? So we're going to get a negative 4x to the fifth. So we'll have some simplifying to do there. And then we're going to have a negative 12x to the third. And here's the other part, is this is x to the fourth times 2. When we've got an exponent raised to an exponent, what do? We multiply. Actually, I gave it away, but yeah. So 4 times 2. Be careful. We are the rules where we're adding, so it's easy to say 4 plus 2 is 6, but no, that's not the right. We're in a different place here. Yes?
What if we distribute the negative?
Thank you. So that's why I always have to. So there's this negative out front that I forgot about. So I was just doing this stuff. So really, what I did is I forgot about that negative. So what I did is I did it without it. There's still this negative out front. Thank you so much. See, that's... And actually, I find when I make mistakes, it's helpful because those are the things that you might make. What I learned most from my Dr. Crittenton, when I, again, was about ready to drop out of school because of math, was he showed us, he told us he would come in purposely and try to forget what he had learned about math and try to show us as if he was just learning it. And so he would make mistakes, and he even told us that was part of his teaching, was because he wanted to teach us how to get out of our mistakes. And I said, that's exactly what I needed. I could watch somebody do it perfectly, but that didn't help me because I didn't do it perfectly. I made mistakes. I need to figure out how to see when I'm making mistakes in that. And so thank you. So I still do these sorts of things. So we'll do this one. X to the 4 times 2 is going to be 8. And now we can distribute. So this negative and negative is going to be a positive, right? Positive 4x to the fifth plus 2x to the fifth. So we can do it as we're combining. We're going to get 6x to the fifth. And this negative times this negative is going to give us a plus 12x to the third. And then it's all over x to the eighth. And yeah, see, why did I write 2? X to the eighth.
The negative 4x to the fifth would actually be a positive. So then you would be subtracting 4 by 2. Or 2 by 2.
Well, no, you said it becomes positive, right? Well, let's see.
No.
Oh, I see what I did. I made two. I made a. So this was x squared times 4 is actually positive x. Thank you. Okay, so this. So I applied it here, but I didn't apply it on the second one. Good. Thank you. Some days are like this. So this becomes negative. So this is going to be a negative 2x to the fifth. Yes, sir.
So why didn't you add exponents when you distribute?
So when I'm distributing x squared times this, that's where I add the exponent. So I took 2 plus 3 to get the 5.
Where did the brackets come from?
These because where we're multiplying, I was not consistently distributing this negative. So when I took negative 3, it was an error that I made, and I had to remember, okay, let me do it without, put the brackets and then do the negative separately. So it's kind of like you have to know yourself, and I know I have problems with negatives, and I should have done that from the start. Let me just do inside here, and then I'll distribute the negative. Some of you might be good at doing both at the same time, but I still have problems with when I work with negatives. Okay. And it's just going to be one of those things. And so I've always had to go back and double check my work to this day. But so did I blow it too bad, or does it all make sort of sense? Right? So the algebra part is the tricky part. The calculus, remember, it was not too hard. I mean, break it to the pieces, take its derivative. Doing that part wasn't too bad. Putting it back together, not too bad. Doing the algebra, that's where we mess up. Okay, the arithmetic in algebra. Okay, this is our last one. We're almost out of time anyway, but again, all we got to do, this looks kind of gnarly. What do? I certainly can't divide these out or anything. It's going to get a little messy, but we'll label this as being top and bottom, F and G, whatever you want to do. So I'll just label them down here. My top function is going to be square root of x minus 8. So the derivative of the top, derivative of x squared, again, hopefully you've done these enough times, you may remember that's going to end up being 1 over 2x square root, right? 2 times the square root of x. And for those that don't remember, x squared is x to the 1/2. So when we take its derivative, the 1/2 comes down. We subtract 1 from that exponent, which is subtracting 2 over 2. So we get x to the minus 1/2 power. The 2 is in the denominator. This is a negative exponent. We tuck it down, so this becomes 1 over 2. There's the 1/2. The exponent is going to come down, so that becomes x to the 1/2, which I can write as that. But after a while, you're going to see we're doing square root of x multiple times. You just want to kind of, okay, I've done it enough, hopefully, where I can remember it. Or I go off and do it over here, and I just write it like this. Derivative of 8 is 0, so that's that. The bottom is square root of x plus 8. And bless you. Derivative of the bottom, again, square root of x, what is it? It's 1 over 2x, 1 over 2 square root of x, and then the derivative of 8 is 0. Okay, I go to put my pieces together, and so the derivative of y is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. And again, as you do these, just write this out multiple times and you will remember it. Okay. So the derivative of the top is 1 over 2x, or square root of x. Derivative of the bottom is square root of x plus 8. Oh, sorry, not the derivative of the bottom, just the bottom, right? Just copying it. Minus the top, which is square root of x minus 8, times the derivative of the bottom, which is 1 over 2 square root of x, all divided by the bottom squared. The bottom is square root of x plus 8. Square root of x plus 8 squared, because that's the bottom squared. And again, this is our derivative. Now there's some algebra involved in getting this. We got enough time to go through that. But what I want is, so the lesson today is sort of here. And in the homework, they might accept this as an answer. On a test, I'd accept it. The thing is, it's in a multiple choice. They might not have it in this form. So then I've got to be able to get them. And that's all I can say is, if this was in the open answer, I would accept this as the derivative. It is the derivative. Algebra needs to be done, but actually it doesn't have to be done. But it might need to be done on a multiple choice question because the form of the correct answer might be different, right? But this is a correct form. I would give you full credit if you stopped here and it was an open answer, okay? But we won't stop here. So we'll distribute this. Let's see, let's change here. We're going to leave the bottom as it is. We won't FOIL that out because that oftentimes get messy and it's not, there's no reason to do it. So we're going to leave the square root of 8, square root of x plus 8 squared in the bottom. We're just going to leave it like that. That's standard practice. But we're going to simplify the top because there's probably going to be some like terms and stuff. So what I'm going to do, I could... What does the textbook do? I think the reason I chose this one, I'm going to show you a technique that I think this is what the textbook will do, is there's this 1 over 2 square root of x. So one method is when we've got a sort of complex fraction, a fraction, and a fraction, is to get rid of that fraction in the top by multiplying by the denominator. So if I come up here and I multiply by 2 square root of x, the whole top, what you're going to see is it will cancel out this as I distribute it to this term, and when I distribute it to that term, 2 square root of x divided by 2 square root of x cancels out, right? So in the numerator, they just canceled out, which sounds, oh, that's kind of a cool trick. Could I just do that? But can I just multiply by 2 square root of x? No, because that will change what we've got, right? But what if I multiply by 2 square root of x divided by 2 square root of x? That's a form of 1, and I can do that. Okay? So what it does is it simplifies the top, but then what I've got is down here, I've got a 2 square root of x that doesn't go away. So I'll just move it over there. Oh, sorry, 2 square root of x. So my denominator is going to look a little different, and I think this is the way they approach it. It's one way. And then, what do we got in the numerator? Well, now it's a lot simpler. We don't have to FOIL this up. We're going to get square root of x plus 8. That's this first part that goes there. And then I'm going to, this is gone, so I'm going to distribute this negative. Negative square root of x, distribute it here, plus 8. Now I take my new denominator, I'm going to leave that. Notice x square root of x minus square root of x, those cancel. 8 plus 8, that becomes 16. And I'll just sort of cross them out and say now we've got 16. So my final answer just has 16 in the numerator, and I've got this denominator. Did I lose anybody on that? And please, if I did, just let me know. Okay, so my final answer, 16 over 2 square root of x, square root of x plus 8 squared. And you'll see the reason we don't square out the denominator is typically it's not going to simplify to anything any nicer. It's not that it's wrong, but again, it's usually not done. Usually we'll just see it left something like this. But again, what you see is that the actual process of taking the derivative is not incredibly terrible. It's actually, it simplifies it in a sense, but we have to do it and then put it into a formula. The difficult part with these is the algebra and the arithmetic that follows that. And again, sometimes you'll need to do it, sometimes you won't. So if you go through, always just sort of, I would always, when you're taking the test with me anyway, I would get to this point, I would circle this, and then I would work on doing the algebra, because that's where probably most of the errors would be made. And at least you've got this circled. I can say, okay, you had a right answer. You made an attempt on the algebra, but you messed up somewhere. Didn't get the right answer, but we had a right answer here. I'm going to actually give you full credit for that. Okay, but try it. Try. But that's the thing. The difficulties of calculus is not really calculus; it's algebra, and I want you to recognize that. And again, in my world, I kind of prefer this better because it shows the whole process is here. I get this 16 over that. I don't recognize that that's a derivative of that anymore because all the evidence has been destroyed in my my way of thinking.
So for the exam, we consider that as
Yeah. I would just stop here. I'd go to the next one, make sure you get everything done. Come back, and then maybe if you got, go ahead and do it. Or don't. I don't care. The question was get the derivative. I got the derivative. I can make a strong case for that. So I'll make it for you. You don't have to do it. Okay. But, and again, even on the homework, they might accept something like that if they ask for the derivative. Give it a try. It's the checking system. I have no control over that. Or they might want it simplified, but I think a lot of them, they'll accept this. Just move on. If you want, maybe later on, practice with it. But if you're struggling with algebra, I want you to learn the calculus part. We can work on the algebra later, but a lot of stuff, when you go to use this in a business setting, whatever you're doing, typically you're going to have computers doing a lot of this for you anyway. What I want you to get out of this is the concept of rates of change. Okay, this is a derivative, so that means it's how things are changing. That's one type of decision. Oh, this is a function value. That's an amount. So I take those numbers and I put them in my decision-making process differently. Rates are always about the future. Where are we going, right? We're going up, we're going down. How fast is it all happening? So that's what I kind of want you to pick out, the details of actually doing all this. You'll hire people to do that for you to get the details, but picking up how we use it. I think that's it. Yeah, that's the last slide. So this is a very sort of a skill-based technical thing. There's just really those two formulas, derivative of a product, derivative of a quotient. They're very similar. Just use those and go forward. And then if you get time this weekend, start working on the reviews. So at least you know what questions you have. At least take a look. Next Tuesdays is kind of open question day. So you got questions, bring them in.